All right, guys, tomorrow is your test for Chapter 7, okay? You will not be able to use calculators. So don't come in here thinking you're going to. Make sure you understand that. The answers are already posted. I put these in modules. I put them there yesterday, so you guys can reference them. I'm going to go over. I'll work through a few problems, but I just want you guys to make sure you understand what's going to be on your test tomorrow. One question will say to solve using matrices and elementary row operation. That is this. That is when you have to show me the row 1 times the row 2 and all that good stuff. Now, some of you are still having a lot of issues with this. Guys, if this is a problem that is really stumping you, save it for the end. Do everything else and then come back to this. Don't lose all of your time on one problem. Okay? That's very important. I want you guys to understand that. Yeah.
So I forgot how the order goes.
I'm going to do this one in a second. Okay. But I just want you guys to see that the answers are up there. But you will get an ordered triple. You guys need to write your answer as an ordered triple or an ordered pair. If you just leave it as x equals y equals, that's not complete. We need to write the ordered triple or the ordered pair. So you better understand that. All right, you're going to have some type of word problems where you're going to have to write your system of equations and then solve for x and y. You guys are going to have to add, subtract, multiply matrices. Now, you need to understand when you can and can't multiply and when you can and can't add. What are the rules for adding and subtracting? Dimensions have to be what? The same. All right? If you're going to add two matrices together, it has to be like a 2 by 2 plus a 2 by 2. Or if you're subtracting, it's got to be a 3 by 3 minus a 3 by 3. All right? That's very, very important. So if you have a question like this, like number 1, and it says you're adding or subtracting, yeah, you can go ahead and multiply if you want to multiply the 2 in and the -4, but you cannot combine them past that because the dimensions aren't the same. So if you get a question that you cannot multiply or you cannot add, say something like dimensions aren't the same, impossible, something to where it lets me know, okay, this isn't right. You notice here, why can we not multiply? Because the middle's not the same. Do you see how the middle was circled and then written underneath was not the same? That's why you can't multiply, right? You guys got that? Okay, and I'll go over a couple of these. I just want to make sure you guys are on. All right, so look at the next slide. Again, you're determining here if they are inverses of each other. If it says to determine that two matrices are inverses of each other, notice you have to multiply forwards, quote unquote, forwards and backwards, A times B and B times A. And notice that when you get the identity matrix, when you multiply them both ways, that's what proves that they are inverses of each other. You have to get that identity matrix. If they just ask you, hey, find the inverse, this is what we do. Remember, you're going to find the determinant first, that A times D minus B times C. We did that a million times with Kramer's rule. You put it out in front, and then you distribute after you change. Remember, we switch top, left, bottom, right, and then you negate or change the signs of the minor one. And again, I can do some of these in a minute. I just want to go through. You guys are going to have a Kramer's rule, but it's not going to be a 2 by 2. It'll be a 3 by 3. It'll be a little longer. I'll do it here in a second. It'll be something like this, where you're finding the determinant. If you have 3 variables, you're going to find 4 determinants. Remember, you find the coefficient determinant first. Whatever that is, you divide every d sub x, d sub y, d sub z. You divide by the determinant that you find right here. And again, you might get a fraction, but you shouldn't get anything crazy. If you get something like 917 over 143, you probably did something wrong. 2/3, that might be okay. All right, so just understand that. Go back and find your mistake. You will have a solving one like this. Couple ways you can do it. You can multiply here. Do you see how you're originally trying to get x by itself? So go ahead and solve for x. Do you see how this is divided by 4? It's the same thing as multiplying by 1/4. If you want to do that, that's fine. If you're dividing everything by 3, it's the same thing as multiplying by 1/3. However you want to write it is fine, just as long as you get the word correct. Inside, notice there's been all fractions. Nothing has been a decimal, so make sure you guys keep your answers like that. Again, these are just some more problems. I think some of them are redundant, but this is just for you guys to work out so you can look at if you have questions. We'll all go over any of them in a second. Another 3x3 Kramer'S. Still, another Kramer'S. It's a long one. This is a finding the inverse. All of these, guys, all of the answers are worked out in modules. I put them there for you guys to look at. Why is this one no inverse on number 3? Not anything times 0. Because you're dividing by 0 here. When you're asked to find the inverse and you find the determinant, when you take A times D minus B times C. We did that right here, and we came out with 72 minus 72 gave me 0. This value, guys, 1 over 0 is undefined. So if you get undefined here, the answer is not undefined. The answer is there is no inverse. So if you're finding the inverse and you come up with, oh, wait, the determinant underneath is 0, that means there is no inverse. Yes, ma'am?
Because if it was the other way around, if it was 0 over 1, would our answer be 0, or would it just be 0?
It would be 0, and then you multiply it and it'd be 0, but that probably will never happen.
Okay.
Why will that never happen? What's the formula here? When you find the inverse, it's 1 over the determinant, right? So that will never be 0 because it's 1 over. Good question, though. Thanks. All right, let's go over this first using matrices one. All right, now you guys are going to walk me through this. We'll do this together. But there's not just one specific way to do this problem. Some people see things differently, and that's fine. Some of you will take a longer road than the other. But what we need to do is we need to set up our problem. I'm going to start over here. And you're going to just, first thing we do, guys, is you're going to write out your coefficients. So 1, 1, 1, and then your answer, -1. Then you have 1, -1, 5. Your answer is 5. Then you have 5, 1, 1, 19. Did I write everything correctly? Yes. If you want to write that little line here that's like, oh, there's my answers over there, that's fine. But what are we trying to accomplish when we use matrices in elementary row operations? What do we want on the diagonals? We want positive ones on the diagonals, and then what do we want underneath? Zeros. So work from the first column over. That's the easiest thing to do. So I look and I have a +1, correct, as my first entry right here. So I'm good. I'm going to leave that first row alone. Whatever you leave alone, go ahead and rewrite. So you say, okay, I'm not changing that. I'm not doing anything to it. So 1, 1, 1, -1. I am going to work on this piece right here. That is what I want to change. I want to change that to a 0. So that means I'm going to leave the third row alone. I'm going to go ahead and rewrite it. Now, our elementary row operation is, what can I do? Can I add or subtract? Can I add 2 rows together? Can I multiply 1 row by something and combine so I can get that one that I have circled? I want it to cross off and become a 0. What could I do? Okay, I can multiply the second row. So -1 times row 2, and I can add it to row 1. What's another thing we could have done? Multiply row 1 by -1, right? Okay, it doesn't matter, but what you guys are telling me that's what you're doing. So write out what you're doing so I can see. I can go back and check. So I'm going to take -1 times row 2. So -1 times 1 is -1. -1 and 1 is 1. -1 and 5 is -5. -1 and 5 is -5. Guys, check me as I go along so I don't make any mistakes. 1, 1, 1, -1, right? Okay, so when I combine these, -1 and 1 is 0. 1 and 1 is 2. -5 and 1 is -4. And -5 and -1 is what? -6. So this is my row right here. 0, 2, -4, -6. Now I'm trying to get 1s on what? Positive 1s on the diagonal and 0s underneath. Now I see something we could do to row 2. I could divide by 2. Do you have to right now? Absolutely not. You don't have to. But I'm going to go ahead, since I see that, I'm going to go, I'm going to go ahead and say 1/2 times row 2. You could also say row 2 divided by 2. That's fine. So, guys, what are we changing? What are we working with? We're working with row 2. So, everything else is going to stay what? So, 1, 1, 1, negative 1. 5, 1, 1, 19. So, if I multiply negative, or 1/2, excuse me, to my second row, this becomes 0. 2 times 1/2 is 1. So, we're divided by 2, right? So, negative 2, negative 3. So 0, 1, negative 2, negative 3. Now, some of you are like, oh, I didn't even see that. That's fine. If you didn't do that, that's okay. At some point, everything will work out if you do your math right. But what we're trying to accomplish is 1s on the diagonal. And I want 0s underneath. So now I'm going to focus on the 5. I'm still in the first column. I just saw that I could divide everything, my second row, by 2 to make the number smaller. That's why I did that. But I want to get the 5 to cancel out. So what could I do? What could I multiply by and combine with to get my 5 to cancel out, become 0? Okay, so negative 5 times row 1 plus what row? Plus row 3. Okay, so that means I am dealing... This is the row that's changing, correct? So everything else is going to stay the same. I still have 1, 1, 1, 1, 1, 1, negative 1. I still have 0, 1, negative 2, negative 3. Now I'm going to take negative 5 times the first row. So negative 5 times 1, negative 5. Negative 5 times 1, negative 5. Negative 5 times 1, negative 5. Negative 5, negative 1, positive 5. Yeah? And then I have the third row, 5, 1, 1, 19. And I combine. So negative 5 and positive 5 is 0. Negative 5 and 1 is negative 4. Negative 5 and 1 is negative 4. And then 5 and 19 is, what's 5 and 19? 24, okay? Okay, so I have 0, negative 4, and 24. So I want 1s on the diagonals, and I want 0s underneath. So my first column is good. I want 1, 0, 0. Perfect. So I need to focus here. This is now what I need to change. But Sophia's telling me, well, wait, can't you just divide? Can you divide the whole bottom row by something? Yes. Do you have to? No, you don't have to. But I'm going to go ahead and do it just because I see, oh, wait a second. It'll make my numbers a little smaller. So I'm going to take 1/4 times row 3. You absolutely, Yes, negative 1/4. I'm sorry. You absolutely do not have to. You could leave that negative 4 and then deal with it how you'd like. But I'm just saying, if you see that and you want to make your problem smaller, feel free. So I'm going to go through. This is the row that's changing. So I'm going to keep 1, 1, 1, negative 1. 0, 1, negative 2, negative 3. So now if I multiply, I have 0. Let me do a different color so you guys can see. So 0, then what? 1, 1, and what? Negative 6. Okay, so what do we want to happen? We want 1s on the diagonals and 0s underneath. So this is good. Whoops. This is good. This is good. This is good. This is good. This is what I need to fix. What can I multiply by? And remember, you want to keep the 0 where it is. You don't want anything to change. What can I multiply what row by that when I combine the two together, that will become a 0? Say it again. What about row 2? Okay, negative 1 times row 2 plus row 3? Okay, so this is what's going to change, right? That's what we're trying to change? So then I'm going to go ahead and say, all right, so I have 1, 1, 1, negative 1. 0, 1, negative 2, negative 3. Now, what's going to happen here? Negative 1 times row 2, so negative 1 here. So negative 1 times 0, 0. Negative 1 and 1, negative 1. Negative 1, negative 2, 2. Negative 1 and negative 3, 3. So now underneath I have 0, 1, 1, negative 6. So when I combine these, 0, 0, 0, Negative 1 and 1 is 0. What's 2 plus 1? 3. And what's 3 minus 6? Negative 3. So I have 0, 0, 3, negative 3. Good. Now look, guys, you have 0. You want 1s on the diagonals. And you want 0s underneath. We are really close, aren't we? What do you notice we could do with that last row? We could divide row 3. We could say row 3 times 1/3 or divided by 3. Because what's that going to do? Divide by 3, divide by 3, divide by 3, divide by 3. What does that leave me with? I'm left with 1, 1, 1, negative 1. 0, 1, negative 2, negative 3. And then when I divide, I have 0, 0, 1, what? Negative 1. So we've done all of that work to now be able to write a system of equations. What does the first equation say? X plus y plus z equals negative 1. What does the second equation say? Y minus 2z equals negative 3. And what does the last equation say? Z equals negative 1. All right, that is part of your answer, guys. You've worked your matrix into our elementary row operation, Gauss-Jordan, however you want to say it. Now we have our row echelon form where it's 3, 2, 1. Now we take our equations and we work backwards. So y minus 2 times negative 1 equals negative 3. Y plus 2 equals negative 3. I'm going to subtract 2 from both sides. What does y equal? Negative 5, yeah? Now I'm going to take both of those values and find out what x equals. So x plus a negative 5, right? Plus a negative 1 equals negative 1. So x what? Minus 6 equals negative 1. I'm going to add 6 to both sides, and x equals what? 5. So your ordered triple would be 5, comma, negative 5, comma, negative 1. Now, the reason I worked that one out with you is for a couple reasons. One, I wanted you guys to walk through it with me. Two, if you look at Miss Carver's answers, she got the exact same answer, but are all of her matrices the same as mine? No. She performed different operations in different orders, and that is okay. But I will tell you, it's very hard. Ted, I'm not picking on you, but it's hard to find a mistake in there, isn't it? Yeah. Just erase it and start over. But if this is a problem that is just like a thorn in your side, save it for the end. Get rid of everything else that you guys know how to do, adding and subtracting and all that good stuff, and save it for the end, all right? You absolutely will have a system of equations problem. It's not going to be crazy difficult. It'll be very straightforward and simple. But if you have an interest problem like this, all right, think about what are the two letters that I could use? X and Y. What would my first equation look like? X plus Y equals what? 33,000. There's two different accounts that you guys have that you're investing in. The total investment is 33,000. So it's one amount plus the other amount has to equal 33. Good. What does the second equation look like? 6% and 10%, right? But we have to write our decimal 0.06 plus 0.10y equals what's the interest? 2780. So there is your system of equations, guys. Remember, if you are given an interest rate, in order to put it into an equation, you have to put it as a decimal. So here are the two equations. Now, some of you are like, how do you expect us to do this without a calculator? You guys can handle it. All right. Some of you on your quiz tried to do everything with decimals and keep it in decimals, and you got so messed up. Don't work in decimals. What can I multiply the entire bottom equation by? 100. So this is going to become x plus y equals 33,000. And then this becomes 6x plus what? 10y equals 2780. Now this is much easier for you guys to handle. Yeah, I'm sorry that I forgot the like here. You guys with me? All right, you can do elimination, substitution, whatever you want. I'm just going to go ahead and eliminate the x's. So I'm going to multiply my top equation by negative 6. So negative 6x minus 6y equals. We have to be able to multiply 33 by 6. You can forget the zeros. If I put 33 up here times 6, this is 18, right? So 198. So this is negative 198, and then what goes behind it? The 3 zeros. Okay. So that's gone. What happens to your 6's? They cancel. What's 10 minus 6? So 4y. And again, guys, forget about the zeros for a second. Everybody in here can say 278 minus 198. What is it? 8 minus 8 is 0. This is going to cross off. So I get 80,000. Okay, everyone in here can divide 80,000 by 4. All you're doing is dividing 80 by 4 and keep the zeros with it. What's 80 divided by 4? So y equals what? 20 what? Thousand. All right, so you're telling me that $20,000 was invested at Y. Well, what was your Y interest rate? 10%. So 20,000 is at 10%. How do you figure out how much was at 6%? You subtract it from the total. What was the total amount that we invested? 33. So what's 33 minus 20? 13. Good. Just because you guys have a bunch of zeros doesn't mean that, oh, it's so hard. Just forget the zeros there for a minute. But there's two parts to this answer. Your actual system of equations that you set up, and then the actual answer to the question. The second example that I have there is exactly the same thing. Exactly the same thing.
Finding the determinant we're going to get the formula?
No. Just do it.
No, I'm sorry, I meant the inverse.
No, it's just 1 over the determinant, and then, yeah.
Are we gonna get our quizzes back so I can?
Yeah, I just told you as soon as I'm done with this, I'll give it to you. All right, let's do one of these. Let's find the inverse here. All right, let's find the inverse. We'll do it here. How do you find the inverse? Well, the first thing you do is you're going to say A times D minus B times C. So A times D. Guys, what's negative times a negative? It's going to give you a positive. So you have negative 7 times negative 18 minus 4 times 33. So what's negative 7 and negative 18? $26. All right, 126 minus, what's 33 times 4? 132. All right, so what's 126 minus 132? What kind of 6? Negative 6. Okay, that matters. So if you're going to find the inverse, guys, you have 1 over negative 6, and then what do? How do we find the inverse? What do I have to do first? Nope. What do I do with the negative 7 and the negative 18? They switch spots. And then what do I do with 4 and 33? You change the signs. You negate. If they were already negative, you make them what? Positive. And now what do? Now you distribute. So if I have negative 18 divided by negative 6, what does that give me? 3. Negative divided by negative is a positive, so here is this 33 over 6. Negative 1 6 times negative 4. What does that give me? 4 over 6, which is 2/3. And then positive 7 6. All right.
33, can you make it 11 over 2?
Yeah, you could simplify 33. This is 11 over 2. Good. And then what do? I was going to do that in a second, but no worries. And then what does my notation look like? How do I write, hey, this is the inverse? A negative 1. Good. So remember, hold on one sec. You have to simplify fractions inside. When you're adding, subtracting, multiplying, you have to simplify fractions inside. Do not change them to decimals. Just simplify the fractions. For an inverse, you have to have your notation. Yes, ma'am?
That was my question.
Okay. Now, for a Kramer's rule problem, I'm not going to work out the entire thing. I already have these all posted for you to work out. How do you find Kramer's rule? What do you do to find or to use Kramer's rule? You're going to find the determinant of what first? Of the coefficients, right? So your first determinant would be 4, -1, 1. Spaced it up. Weird. So 4, -1, 1. Then -1, -4, 6. -2, 3, -5. In order to find my majors and my minors, what do I have to recopy? First and second. So 4, -1, -2. Then -1, -4, 3. Then it's major minus minor. Super important, guys. The order is super important. So you get your 3 majors. You multiply together and add. Then you do your 3 minors. Multiply and add. And then you subtract that value. Then you're going to do that for d sub x. Instead of the x column, what do you plug in? The solutions, the answers. So for here, you're going to plug in answers for the x column. What do you do for d sub y? You plug in answers for what? For the y column. So you're going to just keep finding the determinants, but for whatever sub letter you're looking for, d sub x, instead of the x coefficients, you put the answers. D sub y, instead of the y coefficients, you put the answers. D sub z, instead of the z coefficients, you put the answers. Now again, all of these are worked out. This is all posted on Canvas. You guys have videos for every single one of these lessons. My biggest thing to you guys is take your time and watch your signs. Write everything out. If you have a -4 times a -3 minus, write -4, -3, minus. Make sure you have everything written out. Yeah.
When we do d sub x, like we get like an answer, like
Mm-hmm.
whatever we put for our answer, would we put it over the determinant? Or
You're going to, whatever d sub x is, you divide it by your determinant, and that gives you your x value.
Okay, but like for like say
I'm not going to have lines like that. I'm just going to say use Kramer's rule. I was just trying, like, the review was just like to show you exactly what to do to find each piece. Yeah.
And you said we could use highlighters, right?
Yeah, sure. Highlighters or color pencils. I don't have any, but you're welcome to bring some in. Does anybody else have any other questions? How do you know if you can multiply matrices together? The dimensions have to be what? The same where? All right, so let's just do it. Let me just make one up real quick. I don't know how this is going to work. So this is a 2 by 2. No, hold on.
this one, when we're doing like 2 by 2, is it like row and then column, or row by column, or is it column by row?
Hold on. Seriously, come on, Jammery. All right. If I asked you guys to add these, could you? Why can you not add them? Because the dimensions are not the same. If I asked you to multiply them, could you multiply? Yes, because these dimensions in the middle are the same. What is this going to tell me? What my answer looks like. So I'm going to go ahead and draw a little picture of what this looks like. A 2 by 3 means 2 rows and 3 what? Okay, so give yourself a little mental picture. Now, how do we multiply? If I want that piece right there, where is that located in my matrix? It's in the first row and what? The first column. So that's what you're going to multiply together. You're going to go first row by first column. So 4 times -1 is -4, right? And then -7 and 5 is -35, correct? So what's -4 and -35? negative 39. Okay, that piece is done. Now I'm going to find, enough room here. Now I'm going to find this piece. Where is that located? First row, what? Second column. So I'm going to say first row times second column. So 4 times 2 is 8 plus, what's negative 7 times negative 2? 14. What's 8 plus 14? 22? Okay, so that one's done. Now I'm going to find this piece right here. Where is that located? First row, third column. So that's what you multiply. 4 times 0 is 0. Negative 7 and 4 is negative 28. So what's 0 plus negative 28? Negative 28. Good. Is everybody with me? All right, so now we're going to find this piece down here. Where is that located? Second row, first column. That's what you multiply together. So second row, first column. 3 times negative 1 is negative 3. First column, second column. Sorry, first row. Second row, first column. 6 times 5 is 30. So I have negative 27, right? So now I'm going to find a different color. This piece. Second row, second column. So 3 times 2 is 6. 6 times negative 2 is negative 12. So what's 6 minus 12? Negative 6. Good. And now we're going to find the last piece right here. Second row, third column. So 3 times 0 is 0. And 6 times 4 is 24. There is your answer. And you guys see all the work that I showed. Very basic addition. But you have to, this I think is really important to give yourself an idea of what your answer should look like. Sometimes you can get lost in the which row, which column am I in? So if you write what your answer looks like and then you circle, okay, this is the piece I'm looking for. Where is it located exactly? I think that helps out a lot.
So you're multiplying like the first and the second.
It's always first row. It's row by column. So if it's a 3, so you go first entry times first plus second times second plus third times third. Yep. And again, guys, go back and watch the videos if you have questions on anything.
Would it be like X, Y, Z and like W? Because that was on like the website where it was like.
No, I didn't put anything on that.
I have a question for number 11.
Okay, which number 11?
The solve for X.
Okay, what's the problem look like?
4x plus a.
Okay, 4x plus a
Equals 2B.
equals 2b. Okay, so you're solving for x, right?
Yeah.
So the first thing I would do is I would subtract a from both sides. So you have 4x equals, it's 2 times b minus a. And then you're going to do what? Divide by 4. So what you're going to do is you're going to multiply 2 times the b matrix first. Then subtract a. And then once you get that done, you're going to divide everything inside by 4. So a lot of times it's easier to write it like this. You have your 1/4 on the outside. That's the last thing you're going to do is multiply everything by 1/4. So do your scalar multiplication. Multiply everything in the B matrix by 2. Then subtract A. Then multiply by 1/4 to everything inside. Does that make sense? Yeah. I figured that the addition subtraction wasn't the issue. It's the order of it. All right, how do we feel? All right, test tomorrow. Please be here, guys. Please be here.